So you guys saw in all the previous videos that whenever you have change in magnetic field, an EMF is induced in the conductor, correct? So whenever we have induced EMF, we also have current in this. So today you guys will be learning about eddy currents, alright? Now, why we call it as eddy currents, you will understand in just a minute about it, okay? So have a look into this video. Okay, so you guys saw the video. Now, I want you to notice few things in the video. Now, see, the first thing is, so that metal piece which was inside the coil, it was levitating. That's the first point because of the magnetic field. The second point, it started rotating after some point of time. Did you guys notice? It started rotating. Now, the third thing is it melted and then it just fell off, right? So here, why it was levitating? Because of the magnetic field. Second point, why it started rotating? Now this is where the eddy current concept comes. Now when we say eddy currents, it's also called as a whirlpool current or Foucault current. See, this particular current is formed because of the change in magnetic field in a particular conductor. Alright, and these currents are always they're in closed loops. Okay, they're in loops. This is the reason why that particular metal started rotating. Alright, now the third thing was it started melting. That was because the metal has a resistance and current, it's basically in a closed loop. So because of the resistance, it started heating up. Okay, so what we can say is eddy currents is basically the current which is induced in the particular conductor because of the change in magnetic field. Okay, so since they are in closed loop, they are circular, they are called as eddy currents. Alright, so now you guys understood what is eddy current, right? So we'll see few experiments and examples of eddy currents. Alright, now so look at the given picture. Now what you have is you have a coil and then the current is flowing through the coil, right? Now what we do is we take a metallic disc and we put it on top of the coil. Once current starts flowing through the particular coil, the disc which is there on top of the coil, it starts moving up and down, it starts jumping. Okay, this can be explained by using the concept of eddy current. So what exactly happens here is as the current flows through the coil, there is change in magnetic field, correct? So the magnetic field, it changes, like as it keeps on increasing, the magnetic field keeps on increasing, then what happens? Because of the Lenz's law, it states that the direction of the magnetic field is opposite to what is causing it, correct? So if because of the change in current in the coil, if we get a north pole, the disc will also get a north pole because of Lenz's law. So there is repulsion, it moves up, then because of gravity it comes down. Okay, again it goes up, again it comes down, goes up, comes. So the disc will start jumping around. Okay, so this could be explained why this happens because of this. Alright, so the eddy currents and the Lenz's law. This was one of the experiments, okay, very famous experiments. Now the second one, what you guys need to know, which is very important, you guys will know why this experiment is important in just a while. Okay, see what you have is, let's say you have a metal plate. Okay, so a metal plate, it is moving in an oscillatory motion between two permanent magnets. Okay, like as you can see in the picture. So this is how it moves. Now what happens is there is change in magnetic field, correct? And there is a conductor which is there in the change in magnetic field. So what should happen? There should be a closed loop of current. That's basically eddy current. Now what happens if there is too much of eddy current? You guys saw in the video, right? Now if this metal disc, it should not be melted. I mean, that's not the purpose of it. So we have to somehow reduce the eddy current. Now in this case, how eddy currents will be produced in the particular conductor, it's very easy. So you have north pole and south pole. The metallic plate, it starts moving inside the magnetic field. So change in magnetic field induces current basically. So the current will start forming big loops, correct? So as you can see, there is one loop. So as the plate keeps on oscillating, more and more eddy current will be produced. I mean, that's basically an undesirable effect. So what we do is we use something called as a laminated core. Okay, so now laminated cores are something like this. So in laminated cores, what happens is the electrons should go through a longer path, correct? Longer duration, you can say, to complete the whole loop. So before the whole loop is completed, so in this particular case, what happens, because of more and more resistance, current induced will become lesser. Okay, because current and resistance are inversely proportional, right? So more resistance, lesser the current. So eddy currents can be reduced. So to reduce eddy currents, use laminated cores. Now I told that this is very important. Why? Because in all the transformers what you guys can see, we use these type of laminated cores to reduce the eddy currents. Okay, so eddy currents, they are undesirable, but we have a lot of uses also from these eddy currents. So in the next video, you guys will see the advantages and disadvantages of these eddy currents.